Hello, and welcome to the third iChemie Safety Centre Members Webinar for 2016. Today we're going to be looking at management by targets. My name is Trish Kerrin and I'm the Director of the iChemie Safety Centre. This webinar coincides with the release of a free edition of the Loss Prevention Bulletin that was released in October to mark major anniversaries of incidents that have occurred in 2016. Some of these incidents include Faversham in 1916, so the 100th anniversary, Fezzan, the 50th anniversary, Seveso, 40th anniversary, Sandoz, Chernobyl and the Challenger Space Shuttle, the 30th anniversaries of those. It's also important to remember that it's 15 years since Toulouse occurred, 15 years since the Humber refinery, and 5 years since the Fukushima nuclear meltdown in Japan as well. So today we're going to explore the concept of management by targets. This is when we're driven to make poor decisions based on arbitrary targets or deadlines. A simple way to understand this is to consider Goodhart's law. When a measure becomes a target, it ceases to be a good measure. In this webinar, we're actually going to explore Chernobyl. So, as I mentioned earlier, the Chernobyl nuclear reactor meltdown occurred 30 years ago. On the 26th of April 1986, Reactor 4 exploded with a subsequent fire that burned for 10 days. During this time, however, radioactive material was released and dispersed all over Western Europe. This occurred while performing a safety test at 23 minutes past 1 in the morning. This is when the operators decided to abort the test by pressing the emergency stop button, which inserted the control rods back into the reactor, and we'll take a look at a schematic of that a little bit later. As the graphite tips descended, the rate of fission increased in the reactor and the reactor power surged. The control rods then stopped 1/3 of the way down. In desperation, the operators disconnected the motor clutches in the hope that the rods would descend into the core through gravity alone. The intense heat had ruptured the fuel channels though. The rising pressure from excess steam broke through and the pressure tubes burst. The first explosion occurred at 23 minutes past 1 and 44 seconds, and this ruptured the reactor vessel. This lifted a 1,000-ton upper reactor shielding slab and rotated it by about 90 degrees. This was then followed by a second, more powerful explosion, where lumps of fuel and graphite were ejected from the core, catching fire as they hit the air. 31 people died as a direct result of the incident. Reactor operators, firefighters and emergency responders were in that number. One man died immediately, killed by an explosion, and others burnt in the rubble, one later dying of a heart attack. Tragically, many of those suffered unimaginable pain as they succumbed to acute radiation exposure over the following days and weeks. Let's actually take a look at the Chernobyl flow circuit to better understand this. So we can see here that we have the core situated in the middle, and the water flows into the core from a pump. This water then heats up as it cools the core and creates steam. That steam is then used to drive a turbine, which in turn drives a generator to generate the electricity out of the nuclear power plant. Cooling of the core is required in nuclear reactors because of the enormous amounts of heat that are generated. So let's go back and take a look at the test that was taking place when the operators decided to hit the emergency stop button. At 23:10 on the 25th of April, the station was given approval to reduce power output, which would allow them to conduct a safety test. This was to test if the steam turbines could generate enough power when coasting down to run the main circulation pumps in the event of a power loss, whilst they were waiting for the diesel generators to power up. So this test was basically being done for a safety reason to ensure that they could provide continuous power to their water cooling while they were waiting for their diesel generators to kick in. At midnight, a new shift took over. Now, it's important to note that the reactor was not designed to run at low power, and the operator overshot the test target. The reactor power plummeted to 30 megawatts at 0028 hours. The operators wanted to abort the test at this point in time, but they were overridden by their supervisor, who forced them to continue. The operators began to withdraw the control rods as instructed by their supervisor, and they were able to raise the power to 200 megawatts at around 1 a.m. With only a few control rods in the core, the reactor's capacity for excursion now exceeded the ability of the remaining safety systems to shut it down. At 1:19 a.m, alarms showed that the water level was too low in the core. The operators tried to increase the water flow manually, and by now they had all 8 recirculation pumps running to get water into the core. But they were only seeing small temperature changes and large power fluctuations. The reactor was becoming increasingly unstable. By 1:21 a.m, the caps on the fuel channels were reported to be jumping in their sockets. The control room printout of core reactivity showed the excess reactivity required immediate shutdown. This warning was ignored by the supervisor and the test continued. At 1:23 and 4 seconds, the experiment began by closing steam to the turbine. The momentum of the turbine generator decreased, so did the power it produced for the pumps. The water flow rate increased, leading to an increased formation of steam bubbles in the core. This caused the reactor power to then increase. Now, it's also important to note that in terms of trying to make the test pure for what they were trying to do, they decided to take some additional steps. So they'd actually disabled the emergency cooling system. They'd removed the pump fuses and the valves were chained and padlocked shut. This seems to have been due to the belief that there was a danger of heat shock if cold water was allowed to rush into the hot core of the reactor, despite the fact that that was a fundamental part of the design in creating emergency cooling. Secondly, the test was to be carried out live. Instead of shutting down the reactor and measuring the electrical energy generated by the coasting steam turbine, the plan was to keep the reactor operational so the test could be repeated if necessary. And thirdly, most of the reactor emergency shutdown systems were disabled. In part, this was to allow the test to be repeated if it had failed the first time. It's also important to note that this was the third attempt that they had tried to do this particular test, to test the design rating for running down the turbine to generate electricity. So effectively, the facility was left without its safety backup systems and operating outside its normal operating windows. It's important to go back to the design of the reactor to understand why they decided to do the test in the first place. When the reactor was being designed, the experts recommended that a pressurized water reactor design should be installed for the Chernobyl complex. This design was said to be superior, intrinsically safer with lower emissions than a boiling water graphite moderated reactor. But by 1965, it was clear that the mass production of the pressurized water reactors would be very difficult. In fact, there was only one factory in Leningrad that had the necessary technical expertise to manufacture such a large and complex pressure vessel in the Soviet Union. On the other hand, the inferior boiling water graphite reactor could largely be constructed on site with local suppliers of concrete and piping. Even the graphite blocks could be transported and assembled from modules on site. So this particular technology, the boiling water graphite moderated reactor, was chosen because it was faster and simpler to construct at the site, even though it was recognised as being an inferior and less safe technology at the time. In an effort to try and generate faster commissioning of the facility as well, the commissioning tests were bypassed. because they wanted to get energy production occurring to meet some arbitrary targets that the Soviet Union government had set for the generation of power in that particular region, the area we now know as the Ukraine. So through a series of different design choices that were made and then construction and commissioning choices, the facility was designed with an inherently unsafe aspect to it, whereby the lag time in starting up the diesel generators in the event of a loss of power was too great and would have caused a reactor meltdown. So the test they were doing that night was to actually find a way around dealing with that lag time to try and prevent a meltdown of the reactor should they lose power. So as I said, the startup was driven by the need for electricity generation, not by the design and construction requirements for a safer facility. Therefore, a less safe alternative was chosen because of the speed with which it could be constructed. The unsafe safety test had been approved by the plant manager, who was a turbine specialist and the chief engineer, but he was actually an electrical engineer, not a nuclear engineer. It appears that his interest in assessing the electrical power from the coasting turbine had blinded him to the dangers of operating a nuclear reactor with its safety systems disabled. The people of the town were not evacuated on the morning of Saturday the 26th of April because the senior managers could actually not believe what had happened. Eyewitness accounts of an exposed and burning core were ridiculed all the way to Moscow. Dosimeters that read off the scale for radioactivity were declared faulty because they couldn't possibly be reading that high. The nuclear power plant had been producing energy for 10 years without a major off-site incident, and it was assumed to be perfectly safe by those outside the plant and the senior managers. So this all clouded their judgment in what they were actually seeing and what was going on. Effectively, this also brings in what we now call confirmation bias. They were looking for the answers to questions based on what they believed. So they believed their dosimeters were giving them incorrect results rather than the fact that they were reading off scale. But it's important to note that there was actually a significant failure to learn here as well. In Lithuania in 1983, so 3 years earlier, there was a similar incident that had occurred. The control rods were out of the reactor in Lithuania, and they were decided to be put back in by the operators to control the generation of power. As the control rods descended back into the core, the operators observed a surge in power. The tip of the control rod was made of graphite, the same as they were at Chernobyl. And as the control rods descended, they actually displaced the water. So instead of reducing power in the reactor, it actually increased because the displacement of water removed some of the cooling ability on the reactor itself, and so this created some issues associated with the reactor. Now, unfortunately, at the time within the Soviet Union, there was a significant inability to share learnings across different sites. So whilst there were several people in the Soviet government at the time that knew of this particular issue that had occurred in Lithuania, it was not communicated through to other facilities operating similar or identical sorts of reactors. So the operators at Chernobyl had no idea at the time that when they dropped the control rods into the reactor, that it would actually displace the water, which would cause an increase in power in the reactor, which resulted in part of the runaway reaction being triggered. It's interesting to note today that 30 years on, the town of Pripyat is still an exclusion zone, although there are actually some people that are living in that town. There was actually a very good documentary released earlier this year where some scientists went in to study the effects of Chernobyl 30 years on. And one of the interesting things they found was that there is an entire little village of people living back in that region, self-sufficient. And the reason that they moved back there was because when they were evacuated eventually to other parts of the Soviet Union, they were shunned because they had been in a nuclear radioactive area, and people were concerned that they might get sick from them. So the people were actually shunned in the communities that they were resettled in. So they left and went back to their home. The melted radioactive fuel rods still remain in the reactor building today, and they were effectively concreted in place. Now, there has been recent attempts to reseal some of that area because some of the concrete is actually failing after 30 years of being in place to keep the reactor under control. It's interesting to note as well that as recently as 2012, there were still restrictions in place on farming in some parts of Scotland because of the fallout. The other particularly interesting thing that was in the documentary recently was that they measured the radioactivity present in the forest around the Chernobyl plant. And in actual fact, what they found is that there is no natural degradation happening of the leaves and the trees that were killed at the time. They're all still there, completely in place. So it's effectively a tinderbox waiting to ignite, which is quite concerning because it's highly radioactive. And so we certainly would never want to see that particular area suffer a fire because, again, we have the potential to see radioactive fallout over a lot of Western Europe as well and very highly populated areas. So now I'd like to move on to some of the lessons from Chernobyl. And these have been taken from the edition, the Loss Prevention Bulletin edition that I mentioned, from an article written by Fiona McLeod on this particular issue. And this is where the idea of looking at management by target comes from, and we'll talk a little bit more about that shortly. But effectively, we saw artificial deadlines lead to the creation of shortcuts in the process. There were simplified targets in complex environments that resulted in unintended consequences, such as the commissioning testing not being done to determine how they would deal with the loss of power. There's also something here around leaders needing to listen. What eventually came out in the investigations done in Chernobyl was that the engineers responsible for building it were trying to tell the government that there were problems, but the government was not listening, and the leader and the engineers were unable to tell them those issues as well. And it's important to note that real leaders will tell people what they need to hear, not what they want to hear. And Chernobyl was a clear case of people telling the management what they wanted to hear and not what they needed to hear. Things happen differently on night shift, and I can certainly attest to this, having worked night shift in part of my career as well. The test was meant to occur during the day, but it had been delayed for about 12 hours because there was a need for additional power at the time. So the power station was unable to wind back their generation to do the test. So it was left to occur on night shift when there were less people around to monitor and manage what was actually going on. Another learning is that whatever the designers intend, and often when we design something, we use reason and logic. But unfortunately, humans don't always operate to reason and logic, and this is why human factors in design is such a critical part of the next stages in process safety, because we need to be designing things so that we deal with the issues that humans will come up with different ways of doing things. The sharing of experience and learning is absolutely vital when it comes to incidents. Perhaps there might have been some more consideration about how the test would be done had Chernobyl known about the incident that had happened 3 years earlier in Lithuania. And lastly, that safety is not just about rules and regulations. It starts with design and it evolves with experience. So at this stage, what I'd like to do is invite anyone to raise any questions or comments that they may have, and we'll look to address those as we continue to move through the webinar. There are several other examples, though, of where management by target, and as you've seen in the presentation so far, that was part of what caused the Chernobyl issue. So the desire to get the power plant operational as soon as possible led to arbitrary targets and timelines being put in place that resulted in less than adequate design being chosen and no commissioning testing being done at the time. But there are some other incidents that are a result of management by target. So this is a Challenger incident, which, as I said, it's also the 30th anniversary of Challenger this year. And at the time that the Challenger Space Shuttle was launched, it was very far behind its original launch date. Not only that, the shuttle program was behind in its initial schedule as well. So we actually saw a desire to get the shuttles up and running. It was initially envisaged that they could actually have a shuttle launch once a week, and in fact they were lucky to be getting one every 2 months approximately at the time that the Challenger disaster occurred. So they wanted to meet the launch schedule to demonstrate that the program was working. And you may remember that on the particular Challenger Space Shuttle there was also a primary school teacher, and this was part of NASA's drive to make space exploration relevant to the American people at the time. So even while there was deep concerns about low temperatures at the time of the launch and a lack of understanding of what those low temperatures might actually result in, because the program was so far behind schedule and there had been so much media hype around a teacher in space, a delay to the launch was not acceptable. So this is clearly an example of where we started to see management by targets. Decisions were made and things were done on the basis that people wanted to see the activities done as soon as possible rather than taking the time out to make the right decision. Another example here is Macondo, or Deepwater Horizon. So there was a focus on the schedule and the budget, and it was a focus on finishing the well and moving the rig. And this actually led to some of the decisions where the well kick was not detected, and then subsequently there was the blowout explosion. 11 men tragically lost their life in this incident, and we saw the oil spill in the Gulf of Mexico for some 5 months. So again, a management by target from the perspective of driving towards achieving a certain outcome without fully understanding the consequences of the shortcuts taken to achieve that outcome. So instead of managing the process, we're managing the numbers. The last example I'd like to raise around looking at management by target is Pike River. So this was in 2010 in New Zealand, and there was a focus on getting the mine operational, and in actual fact, at the time, in the lead up to it, the workforce was offered a bonus to increase the mine capability and get the coal mined, even whilst they were still going through the process of finishing some of the design and construction. And this was basically to be able to say that they had achieved continuous mining at a certain point. Once they actually achieved the amount that they were looking to mine, they then actually reduced their mining back again. But effectively they were driven to a particular target of achieving full hydromining by a certain date because there were financial penalties if they didn't. So very clearly again, looking to manage by targets rather than managing the processes that needed to be managed from a safety perspective. So if we think about management by targets, we can often see unintended consequences when people's remuneration is based on safety results. So what decisions are people being driven to make because we're focusing them on achieving a certain target? How do we know that the people in our organisations have the necessary knowledge and competence? How do we know that the facilities have appropriate standards of engineering and design? How are we managing this data, or are we just managing to a target date or a target budget or a target design? How do we know that our systems and procedures are embedded? How do we know the data we receive is accurate? And how do we know whether human factors have been taken into account in the operations? And do we have the right culture? How do we know this? These are some of the important questions to understand to try and avoid getting trapped into this target mentality. I'd be interested if people have any questions or comments on these sorts of areas around the target mentality, because it is certainly quite a challenge to understand how that actually plays out. And one of the aspects of management by target is around the ability to be able to send bad news upwards. So do our leaders want to hear the bad news, or do they only want to hear the good news? If they're not living with that chronic sense of unease, how are they going to spot the warning signs of the complacency? And so Dame Judith Hackett, back in 2013, actually made this quote, that a leader who doesn't welcome bad news will get told everything is okay, even when it isn't. We need leaders who can live with a chronic sense of unease and who can spot the warning signs of complacency creeping in. And so this is very important from the perspective that management by targets can often lead to just doing everything you can to achieve the target that has been set. So that is effectively being told everything is okay, even when it isn't. And that's certainly something we need to try and guard against. So, do we have any questions that have come in at this point in time? Or comments? Not yet. Okay. I mentioned that we had the free anniversary edition of the Loss Prevention Bulletin. So you can actually go to this this link here, icme.org/lpb/free-dig-mag-capture.aspx, and you'll be able to download a free version of the Loss Prevention Bulletin, so the October version. You might remember that a couple of years ago we released an anniversary free edition for Bhopal as well, and we did a webinar associated with that too. So feel free to download this particular edition. It's got a lot of great articles in it. You can read more detail about the Chernobyl incident that did occur in there, but it's also interesting to go back and consider some of the very early things. So I mentioned back in 1916, the 100th anniversary of Faversham, an explosives plant during just post the war, or during the war, so World War I. So that's an interesting interesting article of what occurred there. But there's also some great articles on the Challenger space shuttle in there, and that's certainly where we started to see normalisation of deviance occur, as well as some confirmation bias and, as I said, management by targets. So that actually brings a conclusion to this webinar, unless anyone has any questions or comments that they would like to make. Okay, I've got one question here. How do you ensure that KPIs don't become detrimental to the overall performance? It's a very good question, and that's where you actually need to start to consider what the KPIs are driving. So some of the issues associated with that is looking at when you actually determine a KPI, try and understand what some of the unintended consequences could be. So it's about trying to figure out what people might then try and do to get the result they're after. And often the best way to ensure that a KPI doesn't become detrimental is to have a suite of them in place. And so in actual fact, you'd look at different KPIs because they'll drive different outcomes. So for example, if you are running a vehicle fleet and you want to understand the delivery aspects of the vehicles, then one of the things you might consider is looking at how you actually deal with remuneration from the perspective that if you focus it on people delivering a certain volume, then you're actually incentivizing them to potentially speed, because the faster they go, then the more volume they can deliver at that point in time. So from that perspective, you might also want to look at a metric that deals with discouraging speeding as well, so that you start to see this suite coming together to try and drive the behaviour that you're after, rather than just looking at one particular aspect. So it really does need to be a balanced suite to consider all of those. Another comment is interesting that all the targets discussed were production or time driven. There are equally issues with specific safety targets being set. Yes, I very much agree with that particular comment. So we often see safety targets focused on, for example, lost time injury, or within the process safety sphere around the volume of a spill. And at a certain volume it's categorised one way, and at a greater volume it's categorised a different way. And sometimes we can see a lot of effort going into figuring out that the volume was just under the threshold so that we categorise it in a certain way rather than another way. And it can be interesting at times to see how much effort is put into the categorisation of it. So I think from my perspective, one of the things I've learned previously in trying to address some of the safety related issues is you do need to again have that balance between your lead and your lag, and looking at the quality of what's happening in your lead indicators rather than just looking at the aspects that you see in your lag indicators. So by that I mean, if you're having a lead metric that talks about the number of checks that you're going to do on something, then what's the quality of the check that you're doing and what are you finding in that check? It's not good enough to just say I needed to check my permits. I need to check 1 out of every 10 permits, and I've done that. In that one permit that you checked, what did you find? Are you seeing people actually complying with the procedure, or is there a problem with the procedure? So there are definitely safety targets that are set that can drive unintended consequences. The examples I did use did focus more on the production or time-driven ones, but there are certainly safety ones. And in fact, if you go back and consider that at Chernobyl they were trying to achieve a safety outcome, they just perhaps went about it in a different way. How do you spot innovation rather than a shortcut that may affect safety? So I think from that perspective it really does come down to making sure that you have a detailed risk assessment and management of change process. So if you're going to change something, and effectively that's what an innovation is, you need to make sure you've considered the potential outcomes for that. And that's a challenge because, one, people don't necessarily recognise the change, and so you need to have a robust system in place to identify that there has been a change. And then you need to actually understand the consequences that may arise from that change. And there are some shortcuts that do create issues. Remember several years ago the P-36 oil rig was heralded as a great example of innovative engineering because they didn't follow the standards. And through a series of incidents that resulted, the rig actually completely sank. They didn't follow the standards, so there was a challenge around this innovation that actually resulted effectively in shortcutting in ways that they shouldn't have been done. The next question we have is, can a production target ever truly complement or drive desired safety behaviours, or will there always be a tension? Well, that's a challenging one. I would suggest that I think we need to start thinking about safety a little bit differently. And from that, I mean, we need to be thinking about safe production, not production versus safety. And it's a different way to think about it. It's a challenge to see how we can actually complement it together. But effectively, when we're talking about process safety, for example, one of the key aspects of process safety is that it actually gives us good reliability in our facilities. Now, when you have a reliable plant that's operating, you can actually have a situation where you have a chance to make money depending on what your commodity prices are doing at the time. If you have an unreliable plant, then you definitely don't have process safety because you've got breakdowns and unintended things occurring. Therefore, you've got some things missing in your system. And when your plant's not running, you don't have any chance of making money. So I think we actually need to shift the conversation in process safety and start to talk about how process safety can add value to our organisations rather than it actually being a production versus a safety target. So I think it's a different language. It's a way that we need to start communicating a little bit differently in process safety. And I've got a comment here, goes to show the importance of understanding your mitigations whilst testing your safety systems online. Absolutely, this is a significant example of where that was obviously not done. The fact that they shut down and actually locked and chained off their emergency cooling system because they wanted to create a pure test environment that then resulted in an inability to cool the core when the test went wrong. So again, effectively a management of change issue as well. As you're doing a test online on a system, you need to make sure that you have your safety systems available to you. Things like, if you're doing testing in a particular part of your facility or maintenance in a particular part of your facility, but you're also having to take your fire system offline for maintenance, then what are you doing to mitigate what's going on in case you need your fire system at that particular point in time? Okay, so that seems to be all the comments and questions at the moment. Are there any last comments or questions from anyone, or is there any concerns that I haven't actually addressed or answered any of the questions that you've raised at this point in time? I think it's particularly important that we continue to reflect and remember the incidents that have occurred in our past. And remember those people that were killed. And in this particular instance, this was not only an industrial incident. This was an incident that killed and affected the lives of many innocent children and families that lived in the vicinity of that particular plant. Keep in mind, the power plant was effectively, the town was there for the power plant employees. And I think we need to focus on trying to never let this type of incident occur again. Chernobyl certainly changed the way the world thinks about nuclear power, coupled with 3 Mile Island, which had happened approximately 10 years earlier, and obviously Fukushima, as I said, 5 years ago. We are starting to see, we're still seeing a pushback against nuclear as a reliable energy source, even though there were specific design-related issues in this particular area. It is interesting to see, though, that the UK have just recently approved a new nuclear power plant, whereas countries like Germany are actually going through the process of shutting them down. Sweden have recently shut one down as well, although they've announced that they're going to build a new one too. So depending on where you are, there is still some interest in nuclear power as a relevant fuel source. So all of the material in this particular presentation has been drawn from the October 2016 anniversary edition of the Loss Prevention Bulletin. As I mentioned, please feel free to go and download that particular bulletin and share it round. It's a very important story for us to understand what's actually going on. So, without any other further questions, I might actually wrap up this webinar now. Thank you all for attending. We'll be looking to host some more webinars next year on different topics. If you have any ideas or thoughts about particular topics that you would like discussed, or indeed anyone that you would like to hear from potentially, then please let me know, safetycentre@icme.org, and we can look at who we can actually bring in to for me to interview in these webinars or to offer their insights into what's actually happening. So thank you all very much, and with that I will draw this webinar to a conclusion. It will be posted, the recording will be posted online shortly, and you'll receive an email with a link to that particular presentation. So I hope that answers that last question of can you please email your presentation. It will be available, the recording will be available on the IQME safetycentre.org website. Thank you very much. Have a great day.